Okay, so today's objective 3.1c, we're going to be performing operations on more complex fractions. Focus today on rational functions and radical functions, but not simple radical functions, more complex radical functions. Okay, so let's just remind you how well you already know how to add, subtract, and multiply and divide fractions. So I'm going to take you back to 4th grade. I think it was 4th grade that you learned to add, subtract, multiply, and divide fractions. I'm thinking back to when I learned. I learned in 4th grade how to do it. All right. So if I were to give you the fraction 1/2 plus 1/3, you don't have to write this down. Just watch. What would you do to add those fractions? Common denominator. So what does this denominator want? It wants the other denominator. Remember how jealous they are of each other. So you would multiply top and bottom times 3. What does this denominator want? All right. And then what you would do is you say, all right, so I have 3 plus 2 over 6 because you multiply your numerators. And now they have the same denominator. You can write them over the same denominator, right? And then you get 5 over 6. And then, of course, you always remember with fractions, you have to make sure you can't simplify your answer. We can't simplify 5, 6, so we're in good shape. All right. What if I asked you to erase? Thank you. Subtraction, same idea, right? Simply subtract. What if I ask you to do this? 1/2 times 3/5. Multiply across and try to simplify, right? Ooh, I like multiplying fractions because that's fast. How about division? Keep, change, flip. So if I do 1/2 divided by 3/5, I just do 1/2 times its reciprocal, 5/3, and then I multiply, right? 5/6. Okay, so that's all we're doing. That is all we're doing. Just because we throw an x in the denominator doesn't change what you're supposed to do with these problems. All right, so let's come over here and look at these problems. Here's the one thing we have to look at. Because we throw an x in the denominator, I didn't throw it in there, it's down there. I have to look for what x will make a restriction in my denominator, a 0 in my denominator. So let's find f's domain. I want to know, and the domain is huge. So it's easier for me to just find its restriction than it is to find all the numbers that I'm allowed to use. So to find f's domain, we take x minus 2, say it cannot equal 0. Therefore, x cannot equal 2. So f's domain, so x can be anything else that I want, from -infinity to 2, but keep it open at 2, union 2 to infinity. So see, it's easier to find the domain by finding the restriction. Okay, so there's f's domain. So that means when I'm adding, subtracting, multiplying, or dividing something to 2x over x minus 2, I have to omit x equals 2. I can't use it. All right, let's find g's domain. And that would be my my advice to you before you start adding, subtracting, multiplying, dividing. Find their domain restrictions. So here's what we know about g's domain. X plus 5 cannot equal 0. So x cannot equal -5. So g's domain is all of the numbers in the real number system except for -5. So if I'm combining these two functions, I'm going to bring this over here just a little bit so I can draw the domain number line, so my x number line. Basically what I'm saying, if I'm doing f plus g or f minus g or f times g, I'm not going to talk about division right now, but if I'm going to add, subtract, or multiply these, they share lots of x's, but they don't share -5 or 2. So if I'm going to add, subtract, or multiply them, I have to omit both of those restrictions. Okay, got that? All right, so now that we've talked about that, let's go ahead, and I'm going to color code today. Any changes I make will be in red. Okay, so I'm going to follow these instructions. I'm going to add, subtract, multiply, and divide these functions, and I'm going to talk about their domains. So we're going to do f plus g of x. So I'm asking myself to add two fractions that have unlike denominators. So when I'm going to plan out the way I write this down. So I'm going to do 2x over x minus 2. I'm going to leave a little bit of space so that I can change my denominators, plus x over x plus 5. So I'm just planning ahead here because I know they have to have common denominators. All right, so jealous denominators exist. You know how jealous these denominators are. They're always causing us trouble. What does the first denominator want? X plus 5. So we're going to multiply top and bottom by x plus 5. And I'm going to tuck some parentheses around my x minus 2, whatever that quantity is. All right, so see why I made space? Okay, let's go over here. What's this denominator want? X minus 2 and x minus 2. All right, I'm going to tuck some parentheses around my x plus 5. All right, so I made my changes in red. I'm going back to my pen. All right, so now that my denominators are the same, I like to talk about my denominators first. So x plus 2, x plus 5 that's my new denominator. And now I'm going to add their numerators. But I think I'll distribute as I go just to save time, right? Because I have to multiply 2x times x and 2x times 5. So that's 2x squared plus 5x. You with me? All right, then before I get all fancy and I multiply x times x and x times 2, I have to know what kind of x this is. What kind of x is it? It's a positive x. So I do kind of want to mention that you need to bring that plus up to the x so that you know it's a positive x. Yes. It would be 10x. Thank you. Fix 10x. Good eye. You should play baseball. Okay. Oh, man. You got to keep trying. All right. So now we're going to multiply. Positive x times x is positive x squared. Positive x times negative 2 is negative 2x. All right. There we go. All right. So we have done our multiplication in our numerator. Now we're going to simplify our numerator. We can combine some like terms, right? 2x squared plus x squared is 3x squared. 10x minus 2x is positive 8x. All over x minus 2 times x plus 5. Okay, and you might feel like, all right, I'm done. But I challenge you, or I don't challenge you. That's not the word. I caution you to double check. Are you sure you can't simplify this fraction? You have to look for common factors in your numerator denominator. So let's factor out our numerator just because we're cautious mathematicians. What can I factor out of my numerator? An x. All right, so that leaves me with 3x plus 8. And then in my denominator, I have x minus 2, x plus 5. I'm a cautious mathematician, so I want to make sure I can't simplify this fraction. Do you see any common factors? I don't either, because you have these binomials, but they're not common binomials. And then that x, that's that monomial out in front, doesn't have anything to cancel. So that means that the original solution that we had, or our original expression, is an acceptable response. They're both acceptable responses. I would not ding you for writing either one, but I do like to see you double check. Okay? So let's talk about our domain, because we have to find their domain. What do we know x cannot be? 2 and negative 5. So when we write domains, remember least to greatest, negative infinity to negative 5. Open it up, union negative 5 to 2. Open it up, and then 2 to infinity. And remember, I drew the picture over here so we could see it. So there you have it. We have added them. Now we're going to subtract them. Not much is going to change here, but I will have you clue in on one thing. So we're going to take 2x over x minus 2 minus, clue into that, x over x plus 5. And definitely clue into that minus, because we're subtracting. That's important. And we get our jealous denominators. So our first denominator wants the x plus 5. So we'll give it to our numerator denominator. Second denominator wants the x minus 2. All right. So we now have a common denominator of x minus 2 times x plus 5. And our numerator, we're to distribute as we go. 2x squared plus 10x. But we need to take that negative x, take it up, so that you can distribute. Negative x times x, which is negative x squared. And negative x times negative 2, which is positive 2x. I clean that up a little bit because I like it. Trying to make an arrow, but it doesn't want to let me do it. There it is. Okay. So do you see just a slight difference here? I'm going to move that out of the way. So I got to do some math coming down. So combining our like terms in the top, 2x squared minus x squared is x squared. 10, that's a 10x. Ooh, I forgot that x. And I'm really struggling with the 10x today. 10x plus 2x is 12x all over x minus 2, x plus 5. And we're careful mathematicians, so we want to make sure we can't simplify that. So we factor out our numerator, and we look to see if we can simplify. What do you think? Nope. Did our domain change? Same domain restrictions, right? So your domain, negative infinity to negative 5, union, negative 5 to 2, union 2 to infinity. Keep those unions open. All right, so those are the tough ones. And I don't even think they were tough, right? Okay, so now we're going to multiply and divide. These ones go much faster. All right, so let's multiply. Here we go. F times g of x. So 2x times x minus 2. I didn't mean to put a parentheses there, but you can put it there if you want. X plus 5. So we're multiplying, yes? Okay. But here's what's nice. We don't have to like actually multiply the binomials. We can leave them factored out. So that's 2x squared over x minus 2 times x plus 5. And we do not have to multiply x minus 2 times x plus 5 because then we can't see our restrictions. Done. Can't simplify. What's our domain? Same thing. You got it. Do you guys' arms get tired? Your hands get tired? Yes. Cramps up because I make you write so fast. Man, no downtime. You got to think and write and move fast. Okay, so you can see here an illustration how when we add, subtract, or multiply, the domain restrictions remain the same. Okay, but when we divide, now we have to be on alert. Okay, so we're dividing, and we're dividing a fraction by a fraction. Here's my advice to you. Don't write it as a fraction over a fraction. Do it horizontally, a fraction divided by a fraction, so you can just keep, change, flip. So we're going to do 2x over x minus 2 divided by x over x plus 5. Because otherwise you write it as a fraction, you know you got a complex fraction, and those are never fun. So we keep, change, flip, right? So 2x over x minus 2 times x plus 5 over x. Alert, alert, alert. I'm being weird. Alert. New domain restriction. Look at that. Ooh. Yeah, alert's my favorite word when I'm giving notes. Okay, new. That says new. Domain restriction. Yep, because what is x not allowed to be in this situation? X cannot equal 0. Originally, I couldn't do math over here. If x equals 2, I can't do some undefined number divided by a number. I can't do that. And then I can't do some number divided by some undefined number. I can't do that. So these two restrictions still exist, but now I have another one. All right, so let's multiply. So we have 2x times x plus 5. Don't have to multiply it. We're good. Over x times x minus 2. And I didn't multiply because I want to leave them factored out so that I can do what? What can I simplify here? The x and the x. Exactly. So that's why I'm not multiplying, because I know I want to simplify here at the end. So we have 2 over x plus 5 all over x minus 2. But I have my new domain restriction. So I got to get it in there. So remember what our graph was originally? We had an opening at -5, and we had an opening at 2. And now we have an opening at 0. So now we have 4 sections of the number line. So our domain starts from -infinity to -5, union -5 to 0, be thoughtful, union 0 to 2, union 2 to infinity. But you got to be careful, because you can't do math with x equals 0, because you can't do something times something undefined. Can't do it. So just be on alert when you're doing your division, that sometimes a new restriction will pop up right there in the middle of the process. Okay, so there you have your rational function example. Question? Because I couldn't originally divide by something that's undefined, right? Because this fraction right here, if I plug a -5 here, and a -5 here, and a -5 here, and a -5 here, then I have -10 over -7 divided by -5 over 0. I can't do that math because -5 over 0 is undefined. Those are good questions. All right, so now we're going to work on this radical line combo problem. Now we did some that yesterday that were similar, and I asked you to graph them. This one's a little different. What's different about this radical? It's got an x squared. It's got a quadratic underneath it. You know what this is the graph of? I taught you this in Unit 1. This is a semicircle. This is my radius. What's my radius? 2. It's 2. Square root of 4 is 2. This is not like the ones that we were doing yesterday where we had a linear expression underneath our radical. Now we have a quadratic. So when we go to find our domain, I'm going to do some math over here. So remember that underneath a square root must be greater than or equal to 0. Remember that? But here we have a quadratic, an x squared, which means you might have 2 zeros here. So what we're going to do is we're going to say 4 minus x squared has to be greater than or equal to 0. But let's just figure out what the zeros are so that we can figure out where are the numbers that I can plug in here. I don't think there's very many numbers that I can plug in for x that'll give me something greater than 0. Think about it. All right, so this is 4 equals x squared if I just move the x squared over, right? And then if I square root both sides, plus or minus the square root of 4 equals the square root of x squared. So x equals plus or minus 2, right? But this is definitely a quadratic underneath our radical. So we have to think about our domain, because we know that underneath a radical, a square root, that we have to have positive results. So here are our zeros, -2 and 2. And what we have to determine is where on our number line in our domain will we produce numbers that are positive. So let's start with plugging in a -3. So if I do the square root of 4 minus -3 squared, That's 4 minus 9. What kind of number am I getting underneath my square root? Negative. Can I have that? No, I don't want that. Okay, so this section is, that's not part of my domain. All right, let's plug in a 0. That's 0 squared. So 4 minus 0 is 4, right? That is positive, yes? I like that. I'll take that section of my number line. For sure, I like that because I want positives under here, or zeros. Zeros work too. What if I plug in a 3? Square root of 4 minus 3 squared. Negative 5. Do I want that? I don't want that. So I have to deny my domain. Well, I think you can probably see when you have a limited a number and you're subtracting a square. When you square numbers, they get big really fast. And so if you're looking at this and you start recognizing it, you can see that your zeros are -2 and +2, and that you're only going to be picking numbers that are between. Yes. No, because you have to do the multiplication, the power before you do. It's 4 minus a -3 squared. So that is 4 minus 9. Because you're squaring a negative, that's positive. Okay. It's a good question, though, and I'm glad you asked it. All right, so let's find F's domain. I'm going to erase some of this mess I made down here. So what's F's domain? What do we know? Can I have zeros underneath the radical? Yes. Yes, I can. So -2 I would include all the way to +2. But anything outside of that, I can't put x's. I can't put a -10 in for x. That creates a huge negative number under my radical or under my square root. Right, so there's F's domain. Let's look at G's domain real quick. Should go by quickly. G is what kind of graph? Linear. Does it have a restriction? Totally unrestricted. But if I was adding and subtracting them, multiplying and dividing them on a graph, where would be the only place that I could add, subtract, multiply, or divide? -2 to 2. That's it. I am stuck between -2 and 2. Because even if I do G, and G is everything, it doesn't matter. They have to overlap. And they only overlap in that section of the number line. All right, so here we go. So we're going to do, this is going to go a lot faster. The F plus G of X. I'm wondering if I can even add those two things. They are nothing alike. What do you think? 4 minus x squared in your square root plus, I'm going to put a parenthesis around my line because I have to add the 3x and I have to add the 1. And I'm wondering, can I add those things? Are they like terms? Are they? Pretty sure they're not. You know what? I can do this. I can do the square root of 2 plus 3 square roots of 2. I can add those. That's 4 square roots of 2 because they are the same radical. They don't have anything in common. So I can't add them. Pretty much done. Other than I do need to, I'm going to get a fatter eraser real quick so I can erase faster. Okay. So I do need to get rid of that parentheses, but it's really important that I pay attention to it. All right. So we get square root of 4 minus x squared plus, put a little tail on the end of that, 3x plus 1. Domain, -2 to 2. That's it. Looks terrible. I'm embarrassed to put that in my video. Oh well. Here we go. F minus g of x. Is there going to be much difference in this problem compared to the other one? I think there is. Well, not much difference, but still significant. Because I'm subtracting a line, I have to remember it's a binomial expression, but I have to subtract both the 3x and the 1, so I need to distribute that negative. That's why it's really important to use parentheses when you do substitution. So we get 4 minus x squared minus 3x minus 1, but still, our domain, we can only subtract them where they share x's. So let's multiply. Here we go. We're almost done, folks. Okay, so I'm multiplying a radical times a line. And you know what? I can multiply them. They don't have to be like to be multiplied. I can multiply that square root times both of those quantities. And when I do that, typically you'll write the 3x out in front, and then the square root will be following. Plus, what am I going to write? Really? Can't I just write 4 minus x squared? Do I really need to put a 1 in front of that? I don't think I do. Domain, negative 2 to 2. Okay. All right. Last one. So again, add, subtract, multiply, same domains. But what about division? Let's check it out. What's going to happen? Can I write this one as a fraction since they're not fractions to begin with? Yes. And you know why I want to? Because I want to see if an additional restriction shows up. So I'm going to do 4 minus square root of 4 minus x squared over 3x plus 1. Uh-oh. Alert! I just put an x in the denominator. So that means I got to look for a new restriction. Remember, denominators are not allowed to equal 0. So x is definitely not allowed to be negative 1/3. Okay, so now what I need to be concerned is, does negative 1/3 exist in the original domain of these two separate functions? Yes. It does. It absolutely does. So when I go to look at my original domain of each piece of my function from negative 2 to 2, negative 1/3 is in that original domain. It's somewhere right here. So we have to open up our domain right there at negative 1/3. Now, that's not always the case. So you have to be really thoughtful and careful about it. And you have to place it on a number line in your head or on your paper or something to make sure that it has to be included. Because if this had ended up being negative 5, would I have had to include it in my domain? No. So just be really cognizant of that. So we're going to open it up at negative 1/3. So open all the way to 2, closed. And you definitely want to include those zeros. And there you have it. So I'm going to give you 4 problems to practice, and you have about 19 minutes left of class. It's on Canvas, but I'll put it up on the board.